The weighted average is a really important concept in hydro. We use it all the time. And I want to go over two different ways to calculate it. They give exactly the same answer. They're just two slightly different approaches. So these are kind of typical data we might have. We have an area and we have this area, let's say it's a watershed, and it's got three separate regions with different areas. And there is a value, a measured value of precipitation that applies to that area. And we want to calculate the average precipitation over the watershed using a weighted average, weighted by the percentage of the watershed that is covered by that particular station's area. So the first station measured a precipitation of 50 inches per year and it covered 2 square miles. The second was 30 inches a year, covered 3 square miles, and the third was the largest precipitation, 80 inches per year, and it also covered the largest area, 5 square miles. And we want to calculate the weighted average of the precipitations. So the first method uses, what we would do is we're going to calculate the weights here in the third column. I'll call these weights. And they are going to be defined as the area of that particular region divided by the total area. So we need to calculate the total area. So what I'm going to do is I'm going to sum up these three areas to get the total area of the watershed, and this fortunately just comes out to a nice easy number of 10 square miles, right? And then for each of these subregions, I calculate the weight as the area divided by the total weight. So this is the total area. So I'm sorry, the area of the subregion divided by the total area. So for the first subregion, I have the weight will equal 2 divided by 10, and that's 0.2. The second one is 3 divided by 10, etc. Now, one useful advantage of this way of approaching the weighted average is that if you've done it right, one way to check is that the sum of the weights, if I sum these all up, should be 1. And you can see it is 0.5, 0.3, 0.2. That's equal to 1. And that's a useful check that I've actually calculated those weights correctly. The next step is to multiply the precipitation in each subregion times the weight. And that will be the contribution to the total average from that substation. So for example, the first station, I take the precipitation of 50 times its weight of 0.2. That is 10 inches per year. And for the second, it's 30 times 0.3, which was 9, and I'll just do the last one here, 80 times 0.5, and that is 40. And finally, all I have left to do is to sum these three contributions up to get the total average, weighted average precipitation. So that's 40, 59. So 59 inches per year is my weighted average precipitation. Just to compare, if I just took the arithmetic average, if I just averaged these guys here, the average turns out to be 53.3 or something like that. So the weighted average is quite a bit higher than just the simple arithmetic average. Now, there's a second way to approach the exact same problem. Here are the exact same data. It uses a slightly different technique, but we get the same answer. So in this technique, what we do is, the first thing we do is we just simply multiply the precipitation in each subregion times the area of each subregion. I don't calculate weights at all. So I'm just going to multiply this 50 times 2. And I'm going to get 100. And then 30 times 3 is 90, etc. And next, I'm going to, once again, sum all these products here. So that's 590. And I'm also going to sum all the areas to get the total area of the watershed. Again, I did the same thing up there. It's 10, right? So, and now, to get the weighted average, all I need to do is take the sum of these terms here divided by the total area there. So the weighted average will be 590 divided by 10 equals 59. I get the same answer. Same answer, different way. In some ways, this is a little bit shorter, which has an advantage. On the other hand, doing it this way ensures that you calculate your weights correctly because you can check that they sum to 1. Doesn't matter which one you use. I don't care, as long as you know how to get the weighted average of things like precipitation data.